Classes are a particular kind of type, very common obviously in object orientation. They combine a number of different concepts from programming. In particular, they define a data structure. They support modularization. They allow for code visibility, code reuse, and abstraction. So let's go a little bit through those. So data structure is just the ability to create type that holds more than one component value, component data storage location. This particular example uses a Kotlin data class. So data class provides a little bit of extra functionality. So it says, okay, you want to have these parameters, and it provides equals, it provides toString, etc. That comes with some restrictions in terms of what you can inherit or inherit from. But data classes are there. They are a pure data structure. Just put these things together, and that's the structure. Modularization has to do with breaking your code into different parts that don't always give invisibility into everything that's inside them. You can use classes for this as well. Private methods in a class or in its companion are isolated to only that particular class. So it allows you to hide away things that are not necessary and makes it possible to change them without changing users of your type. Anything that is accessible from the outside is likely to be also used by some code somewhere. So how do you deal with this? You hide it away. You make a private method, or you make it protected, or you make it internal, etc. So it allows you to group your stuff and hide stuff away. That also links with abstraction, where you say, okay, I have this type, I have an interface that needs to be provided. For example, we have the empty list function. It returns a list of type T. It doesn't tell you the actual implementation of the list at all. I haven't checked, but there is in Java there's similarly there is the collections.empty list or empty set that do exactly the same thing. These functions create you an empty thing, but they don't tell you what the implementation type is. It abstracts away that thing. So if something returns a list, and by the way, if you use the list_of function in Kotlin, that's what happens. It looks at the actual data, and if it gets one value, it uses a singleton list. It gets no value, it uses an empty list. If it gets more than one value, it creates a regular array list kind of thing. But again, that is the current implementation. In the future, it might do something else. So abstraction allows you to kind of hide away those differences and handle things and think in terms of the what does this do rather than how does it do it. That also, if you hide away those things, it allows you to have more code reuse, and that is a key property of what you want to use in all code, including classes. And inheritance in particular allows you to reuse code in a rather elegant way. But not all code reuse should be done through classes. If you have utility functions that don't really need the state, you can just use them in utility functions outside or as extension functions. So object orientation does some part of code reuse, but not all of it. And code visibility goes hand in hand again with modularization and abstraction. It allows you to say, okay, this particular code is not visible from the outside. Not only is the implementation invisible, if you create helper functions or something like that, that's invisible. It can be invisible too. So you reduce the complexity of the interface and allow for future changes. And allow for future changes. It also can help making sure that the class or the module is only used correctly, because the dangerous ways of getting at it are hidden away. You can only do something, you can only change the state of the object through the well-checked functions that are allowed to manipulate them, and they do their checks to make sure that the state of the object stays valid. When we have classes, there's a number of things we want to think about. Classes things is, for example, the class invariant. We want to make sure that there are some class invariants are those things that are true for every instance of the class. So an instance is so a class is a type. It's a category of values almost. An instance is a particular value at a particular memory location that lives there. The class invariant should be true for all instances of that implement that particular type. And that allows users of that type to be confident that when they write something, it will actually meet those requirements. There is inheritance is a relationship. So it is a thing. So instead, when you have has a relationship, it's like I want to have behavior of this particular type. I want to have a list inside my thing. But has a is an ownership relationship. And you should not express a relationship that is best defined with a has as an inheritance relationship. Because an inheritance relationship is actually public. So inheritance means that you must stick to the contract of the parent. The parent has certain properties, it makes certain promises to its users, you must stick to those. Everything that is valid to be done on the parent must be valid to be done on the child. Polymorphism allows you to use different things depending on the runtime type. And one particular thing that is interesting is the idea of an immutable type. Basically, an immutable type is one where the state of the object is not able to change. And technically that should be, if you have other instances that are part of that state, those instances should also be immutable, not able to change. And primitives are not able to change, and Java strings are not able to change either. And a nice bit about an immutable type is that you do not have to worry about threads, because once the object has been created, it's in a fixed state, and the JVM makes some guarantees about construction, and after you finish the constructor, it will not allow access to the object outside of the constructor before the final constructor is finished. You need to be careful with calling things from inside your constructor, because there the guarantee is not there. There are many kinds of classes in Kotlin. So conceptually there is the nested class. So that's a class-ish thing defined inside another class. That gives that nested class a little bit of access to the outer class, to the private members of the outer class. It also gives a kind of, it communicates that this class is related to the outer class. But most of the way nested classes behave like regular classes. An inner class is a form of nested class that actually maintains a link to a specific instance of the outer class. So they are created in the context of an instance of the outer class. You cannot create them independently, which you can with a nested class. An inner class keeps a link to the outer object that it was created with. You can just create it by having an object instance and then the dot inner class type name. Most of the cases an inner class is created by code in the outer class, and obviously at that point that doesn't matter. You can have open and final classes or closed classes in Kotlin, or in Java as well. So a final class, which is mostly the default in Kotlin, except where it is not sensible for it to be the default, like in an abstract class that must have children. So final means that you cannot inherit it. You cannot override a function. So a function can also be final or open. Same way, are you allowed to inherit it, to change its behavior? The idea of having something final by default is that if you want to maintain these invariants, even if some subclass is trying to might want to do its best to break it, so if it's important that the invariant isn't broken, you need to design for that. If it's final, it cannot be broken that way unless you go hack into the JVM and override that final property. And yes, that is possible. There's a COMSUN unsafe class that gives you all kind of powerful capabilities to do that kind of stuff. Of course, security managers can forbid you to do that as well. And final does it. So an open basically means you are allowed to inherit this. A sealed class is a type that can only have children within the same file. The Kotlin concept. And that allows you to control which children you have, and it therefore also allows you to have an enum that checks for every possible subtype. In the assignment you saw this for the player type. Was a sealed class that had two children, the computer player and the human player. Both of those could be were open, that you could inherit from them, or the computer player was even abstract. It did not have an implementation for its make move function. But because it's sealed, we know that a player is either a computer player or a human player. There's no other subtype of player, thereby making it easy for you to implement the computer player correctly by inheriting from the right class. And for the checks to be valid, to say, okay, I'm a human or a computer, I just make that check and it is going to be valid. It's not going to break. Because normally checking types on things can break if someone creates another subtype. Data class, like I said, is a class that adds some, by default, makes it easy to create data structures basically, and it adds a lot of default methods that you want to do. You can do it all by hand, but data class makes it nice and concise. You can define a data structure on one single line of code rather than many lines. And there are some, if you have a data structure with 4 variable properties, like the address thing I showed you before, if you do it fully, if you implement fully what data class provides in Java, you'd probably need about 150 lines of code, including white space, yes, but way more than you want to have. And it's all boring code and all can be automatically generated as well. Objects. Kotlin has a specific type of class that is a singleton, basically designed for singletons only. So it will create a single instance of that class. There's no constructor because it doesn't make sense. It is a type, but it also has an instance. And in particular, an interesting concept that Kotlin has is the companion object. Basically says that for every class, we also have an object that combines it. This replaces what in Java is the static members, so static methods or static fields, etc., that act on the class, so to speak. Companion object is an actual object. There's only one of them, shared by the entire, one of them for that particular class. But a companion object can implement interfaces, for example, or it can even inherit classes. Objects can inherit classes or interfaces. You cannot inherit from an object because there's only one instance. You then would be able to create a child of it. No, that doesn't work. An enum class allows you to define a type with a list of instances with each a name, and those instances can have their own overridden implementations as well. This is Very close to an object actually, but a bit different. And this maps also with the Java enum. So basically, a key use for here is if you have a limited set of values, you can use an enum class to create that type. You know that only those values will be there. They are named, so much more readable than if you have numbers. And because of the way it is implemented, it is more or less the same efficiency as if you were just using numbers, but it's much more readable. And of course, if you want to use the polymorphism aspect of enums, you can also do that instead, still efficiently. But a difference between an enum and a sealed class, like a sealed class says these are the children, but you can have multiple instances of the same child type, whereas an enum class cannot. But it mirrors very much a sealed class with only object children. So a sealed class can have an object child. Obviously, an object child has only one instance, etc. An abstract class is one where you leave something out. You can create a class and say, okay, my children will have this function, but I don't have it because in my context, if you have a vehicle and you have a drive function, well, you don't know how to drive a generic vehicle. If it's a car, you can do it. If it's a bicycle, you can do it. But for any vehicle in particular, you don't know how to do it. You leave it to the children, the actual instances or the children that says, okay, this is a particular kind of vehicle, who provide that implementation. Finally, we didn't really cover this. There's the annotation class, which is basically like an interface, but for the annotations, it says, okay, you can actually in your code specify values that are attached to certain code elements. And those values are then created to implement the interface of the annotation class. So it's a specialized interface effectively. An interface is basically, it's like an abstract class, but it doesn't provide any implementation. Originally, now you can provide default implementations, but again, it does not have any state.